Welcome to the final chapter of college algebra, and it's all about matrices. Some of these problems you have done before, some of them you have not. And in fact, today, no one has seen this particular method before, so this is exciting. I learned this method in college and thought it was jolly good fun. Just was kind of fascinated with the whole process. So what we're learning is what's called an augmented matrix. We're using augmented matrices, and yes, we're still solving systems of equations, because that's the number one thing we do with matrix operations, is we solve systems of equations. And yes, there will still be some fun and exciting word problems yet to come throughout this chapter. So in our first example here, I just want to explain to you what an augmented matrix is and why it's called an augmented matrix. In the past, we made a matrix of the coefficients on the x's and the y's. And give me one sec here. So we made a matrix out of those four numbers, and then we made a matrix out of those two. Well, now we're not going to do that. Instead, we put all of it into one matrix. That's why it's called an augmented matrix, because it has both the x's and y coefficients as well as the numbers it's equal to. So when you turn this into an augmented matrix, that part of it is actually quite simple. You're simply going to write it as 4, 1, you're going to get your x coordinates, or your x coefficients, excuse me, -2, 3, your y coefficients, and we draw a little dotted line. Not essential to draw the dotted line, but I will try to remember to do that. -6, 11, showing that, oh, that's the numbers it's equal to. And so now you've created an augmented matrix. Now, what we're going to do is what are called row operations that I will get to here shortly. We're going to transform this, and our goal is to turn it into an equation that looks something like this. I should probably go that way. So here's the goal matrix, if I can spell. And so what we would like to end up is something like this. 1, 0, a number, doesn't matter what number, 7. We want a 1 down here, though. And then, of course, 2 numbers out here. The key thing that has to happen, and this will be easier to see when we do a larger matrix, is that we want the 1s to form a diagonal, and we want a 0 here in the bottom left corner. That's called triangularizing your data. We want to create that triangle with 1s and 0s. Okay, why, you say, would we want to do that? Well, watch. If I turn this back into an equation again, I have the equation x plus 7y equals -3. And then notice the second one, I would have a 0x, and I would have a 1y equals 5. So what have I found out? I actually have solved this, and I know that y equals 5. Once I know that y equals 5, I can then do normal substitution, go sub that back into the earlier equation, have x plus 7 times 5 equals -3, and I can subtract 35 over and get x equals -38. I have now solved for x and y. I know the solution is -38.5. So if I can get it in that form with 1s in the diagonal and a 0s in the corner, I can then solve the system of equations by simply substituting in the values. Okay, now this is a little easier to see, though, when you're working with a matrix with 3 variables. So you'll see I have here the original system of equations. I turned it into an augmented matrix, meaning I joined the 2 matrices together, and so considerably more numbers. And my goal, what I was out to get, is over here. Notice, once again, I have 1s in the diagonal, and I have everything below that is zeros. That has to happen because, once again, I can now solve this same thing and say, okay, well, the top line gives me x plus 2y minus 3z equals 2. The second line gives me 1y plus 5z equals negative 5. And the key third line tells me that z equals 4. Once I know z equals 4, I can then sub that answer back into the second equation, solve for y, and then sub both those answers back in, solve for x. So if you can get it into that triangle form with ones in the diagonal and zeros in the bottom left corner, you've got an easy solution. So now your question would be, how do I get it from one form to the other? Okay, well, that's what we call creating row operations. And if I create row operations, we're just right here. I'm just going to have you practice trying to follow the row operations. I've written out to the side the row operations, and you kind of have to learn the symbols for what it wants you to do. So what it's asking for you to do here, the first one, just looking at this little 2-row matrix, it says row 1, double arrow, row 2. That double arrow simply means switch the rows. So now, why would we be doing this? Well, we just said we always want a 1 in the top left corner. So if I looked at this matrix, I would go, oh yeah, I want to switch the rows so that I can have the 1 in the top left corner. Okay, so I would have done that particular process. Now, I want to take this matrix, and I'm actually going to move, well, I was hoping to move. Hold on. Whoa, okay, I'm obviously killing things I shouldn't be killing. Okay, I want to actually take and move this equation down here. So now, for my second row, my second set of row operations, this is a little trickier. It's telling me, and essentially what it's trying to do is elimination. It's telling me to take -2 times row 1, add it to row 2, and then the arrow means where to put the answer. So this is telling me in this particular case that I need to put the answer in row 2. So think about it here. It's telling me to take -2 times row 1. So I'm taking -2 times that first row, first number, add it to row 2. What am I going to get if I take -2 plus 2? Yes, I'm going to get 0. Now the question is, where am I supposed to write that answer? Okay, well, since it said I should write the answer in row 2, what's that mean I'm doing to row 1? Nothing. Excuse me, get another color here you can see. I'm leaving row 1 alone. It's not telling me to change row 1. I let row 1 sit. So I'm taking, we just figured out -2 times row 1 plus row 2 would give me a 0. Now, you're going to do that, though, every single time. Now I'm going to take -2 times the second number in row 1, add it to row 2. That's going to be -8 plus 3. So that's going to give me a total of -5. Okay, if we do it one more time, then I'm going to take -2 times the top row, add it to the second row. So -2 times 7 would be -14, plus -5 would be -19. And so I would have arrived at that set of answers. Okay, that's a general idea of how row operations work. We're going to try that again, except we're going to try that over here with one that is a 3-variable, 3-row matrix. It gets a little more complicated. Okay, in this case, it's trying to do the same general task. We're trying to First of all, create a 1 in the top left corner. There's actually a lot of ways I can do this. In this case, they have elected, or actually I have elected, it says take -2 times row 2. So if I took this first number times -2, and then I'm supposed to add it to row 1, -4 plus 5 would make what? Yes, indeed, it would make a 1. So therefore, we would be putting 1 in our top left corner. Then it wants me to do that same thing. So each and every time I'm going to go take row 2 times -2. So if I take row 2 times -2, sorry, I'm trying to get this, see if I can change the magic pen color. So if I'm taking row 2 times -2 and then adding it to row 1, that's going to give me positive 10 plus -3 is 7. And so then that number becomes a 7. Okay. If I do it again, same general process. If I take row 2 times -2 and then add it to row 1, -6 plus 4 is 2. Excuse me, -6 plus 4 is -2. And, sorry, that last one was 7. Okay. Keep going, do it again. Take row 2 times -2 and then add it to row 1. -2 plus 7 is going to give me 5. So I'm going to get a 5 out of that deal. Okay, and notice I didn't talk about that, but it said put my answer in row 1. I read that, but I didn't emphasize that. I knew to write my answer in row 1 because it said to put in row 1. Plus, I also know I'm out to get a 1 in that top row. Okay, the next one is now attempting to get us a 0 right here. Your goal is to always get the 1 in the top row and then get zeros down below it. So I want to get a 0 here. They've opted to use, once again, there's lots of different row combinations you can use to do this. In this particular case, we've opted to do 3 times row 2 plus 2 times row 3. The question is, where are we putting the answer? Answer goes in row 2. So here we go again. If we do that, it says take 3 times row 2. So I'm taking 3 times row 2 plus 2 times row 3. 6 plus -6 gives us 0. Hey, we got what we wanted. Okay, keep doing it. This time I'm taking 3 times row 2 plus 2 times row 3. So that'd be -15 plus 12. -15 plus 12 is -3. Do it again. 3 times row 2 plus 2 times row 3. 9 plus -8 is going to give me a 1. And then last but not least, do it a third time. Take 3 times row 3 times row 2 and add it to 2 times row 3. That's going to be 3 plus 4, which is going to give me 7. Okay, at this point, I would have probably also done something to the third row, but right now, since they didn't tell us to, I will just copy it down. If they don't tell you to change a row, you leave that row sitting there alone. Now, you may find it complicated to do more than one set of row operations in one matrix at a time. So if you prefer to draw a different matrix each time so it makes more sense, that's a great idea. Okay, that's the basic premise of how you do row operations. I'm going to stop the video and start a second one where we're actually going to solve the matrices.